Stat students, we're going to go over the significance tests, Khan Academy unit test. Got 14 questions. Hopefully we can do them fairly quickly. If not, I'll speed up that video. Let me zoom in first. Okay, so this whole thing, first of all, is dealing with all of this in the reference sheet, specifically everything up here and everything down here. So we're talking about just one sample, proportions, or one sample, mean, data. And you've already seen these formulas in the, what do we call it, sampling distributions unit test. And now we're just applying them to answer questions. Okay, so here we go. So we're doing a test on a t-test for means. Now, t-test for means, I'm just going to say it, need randomness, need more than 30 sampled, or they need, what's it called, asymmetric distribution. And then they also need to be less than 10% of the population of interest. So let's see here. We took an SRS, that is a simple random sample, so check, we did randomly sample. Is it approximately normal? Well, let's see here. We only took 10, so since it's less than 30, it still could be approximately normal. Just check to see what it says. Our sample data was skewed right. Okay, so since we sampled less than 10 and it said it was skewed right, this condition is not met. Okay, now is it independent? Well, there's 1,000 people. What's 10% of 1,000? 100. We definitely sampled under 100, so we actually get that check. So we did sample under 10% of the population of interest. Okay, again, 10 to 1,000 is less than 10%. We did do a random sample, but because our sample was less than 30 and skewed, we can't say it's approximately normal. So let's just talk about this real quick, and then I'll go more quickly through other examples. If it had said we sampled more than 30, so if it said 30, we sampled 40, we sampled 32, and it was skewed right, that would actually be okay. So if it's 30 or more, you are totally safe and just click this without thinking about it, regardless of what this says, which is kind of weird. But if it's less than 30, you need to go by what this says. If it says it's skewed in any way and not symmetric, you are not allowed to click this if the sample size is less than 30. All right, let's keep on going. So next we have a hypothesis test, and we have alpha 0.10. So what should we conclude? Well, okay, we have a p-value, we have an alpha, and the main idea is that if the p-value is less than alpha, we can reject. Okay, so it's definitely A or B. Now let's see what we were trying to reject. We were trying to see if we were just filling drinks with the automated amount. So in other words, if we're going to reject HO, then we're saying that it actually is different than 530. So since we're rejecting, there is evidence. That's also things that you say hand in hand. If you reject, there is evidence. If you don't reject, there isn't evidence. So in other words, B and C are nonsensical answers. If you reject, there is evidence. So it's only A. B's out. That doesn't agree. If you fail to reject, there isn't enough. So C is out. Nonsensical. Again, we're rejecting HO. There is evidence that HA is true. In other words, that it is different. And onward. Okay, I have another test. So assuming the conditions are correct, what is the correct inference? Now again, notice here that we are dealing with proportions. So the Z statistic for proportions is, let me write it like this. It's the sample proportion. So let's see what that is. We sampled. Okay, so we had 18 customers out of 50. So what's 18 out of 50? We need that as a proportion, not as 18. So 18 out of 50 as a proportion is 0.36. So we got actual, AP, actual minus predicted, 0.36, minus the predicted, which was 0.3, divided by, and our standard deviation is made up by our null hypothesis. So it should say that somewhere. Okay. So assuming the null data was true, that's what you do in a hypothesis test. You assume the null is true. So we're going to base our standard deviation on the supposedly true 0.3 times 1 minus 0.3, which is 0.7, divided by the sample size, which was, again, 50. So this is your correct Z statistic. So let's click that one. Oops, 0.36 minus 0.3. There we go. Okay, so your actual data value minus the assumed data value, and in a test, the standard deviation is based on the assumed truth. Now, in a confidence interval, your standard deviation is based on the sample data. So let's just be aware of that. Okay, up next, just writing the hypothesis test. So number one, A is out. HO should always have the equality symbol in it somehow. So if it says straight up non-equals, that's out. So Has to be these two. Now, we're also testing to see who's less than 25, so clearly less than is the symbol, so again, if you read the rest of the wording, I'm just skipping ahead because I've seen this question a few times, but read through the material. This is saying we would assume it's 0.3, but is there evidence that it's less than 0.3, essentially? Even though it says 25 years old, the percentage associated with being 25 is 30%. So is it 0.3 or is it less than 0.3? Oh gosh. Speaking of reading. This really upsets me. Okay, yeah, sorry. Make sure you read this line right here. Silly me. So remember when I said read the prompt? Read the prompt. Okay, onward. So we got a test statistic. What is the p-value for t of 2.441 with 8, or sorry, 411 with 8 observations? Let's see here. T-value. If your sample size is 8, you're looking at degrees of freedom 7. The question is, where does 2.411 fall in between? It falls in between these two. So we know that the p-value is in between 0.025 and 0.02. 0.025 and 0.02. Which is the same as saying this, just a broader range, but still true. Okay. Now a z-value and a p-value in alpha. Okay, so this time our p-value is way greater than alpha. Again, you can read the whole test if you want to, but since the p-value is greater than alpha, we can't reject. So in other words, there's not enough evidence. So we can't. And we're done. Okay, so now we're doing a t-test. So what do we get for a t-test? And the way you find a t-test statistic, it's really eating me up that I got the last one wrong, but again, that's why you need to read questions carefully. I'm just trying to go fast for my time limit, but take your time as you go through this. So let's see here. If we take a random sample, our actual amount is, yeah, a mean of 48 minus an expected mean of 45, read the problem, divided by our standard deviation, and that standard deviation is always divided by the root of the sample size. So that is our correct t-value. Looks like it was the first one, actually. All right, now again, I'm not making that up. That's totally coming straight from the formula. You can see that a standard deviation is divided by the root of its sample size here. So you need to know how to calculate a z-statistic, which statistic is another way of saying actual. Parameter is what you assumed it was, and then standard error is what we get in these two formulas here. All right, moving right along. Okay. So this time we have to review what type 1 and type 2 error is. Type 1 is rejecting HO when we shouldn't. Now, when would you reject HO? If your p-value is small, okay? Now, type 2, just in general, just to say it, is not, not rejecting HO when we should. What does that mean? It means essentially our p-value wasn't small enough, but HO is actually not true. Okay, so now notice what's going on here. They're saying if we lower alpha. Now what happens if you lower alpha? Alpha, if you remember, I'm just going to write it like this, assuming we're doing a greater than test. Alpha is your cutoff to how far a value has to be. So alpha 0.05 would maybe be about right here. Alpha 0.01 would be around here. Again, if you know your z-scores and normal distribution, you know that this happens a lot rarely than getting something this far. So if you make alpha 0.01, you're going to get a much rarer, you're only going to reject if you get a very rare result, which if you think about that means you're only going to reject HO with more likelihood that it actually wasn't true. In other words, if you find something so rare, it probably didn't happen by chance. So if you actually lower alpha to 0.01, you're making it less likely that you'll reject HO. All right, again, think about this. Alpha 0.05, you could reject it in all this space. Alpha 0.01, you only have this small little area where you're allowed to reject. So you're actually decreasing the probability of rejecting HO when you shouldn't. Okay, up next we have this crazy thing right here. Okay, so our sample result was 0.6, and we're just doing a not equal to test. So that means we need to find both sides where 0.6 or more is as rare or more. So 0.6, there's 1, 2, 3. Now a rare result would be 4, 5, 6, 7. So those 7 dots. On the other end, since we're doing a not equal to tests, that would be 0.4 below. There's 1, 2, 3. So in total, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 results that are as rare or more on either side, not equal to, a point of the expected 0.5, based on this being our sample. So there are, again, 10 out of 125. Well, what's 10 divided by 125? What is the probability of all those? Whoops, 10 divided by 125. We get 0.8, so there we go. Okay. Science practice. It's curious. Significantly better or worse. Now again, that just means different, not equal to. So also it has to be based on what the null was supposedly. So in other words, what the assumed truth used to be. So not based on the sample data, what we thought we should get. That's what hypothesis tests use, what you assumed would happen. So not equal to what we assumed would happen. All right, again, here we go. So this is the conditions test again. Did we sample randomly? Okay, we got a random sample, so yes. Do we have 10 successes and 10 failures at least? Well, what is 4% of 500? 0.04, that's 4 as a percent of 500. That's more than 10. And obviously if 20 are 4, then there are 480, the opposite of that, in terms of 500, against. So there are 20 in favor, 480 against, that's 10 either way. Now is this independent? Now if we sample 500 of 20,000, well, what is 10% of 20,000? Okay, we definitely sampled under that. So again, we met everything. We have 10 or more successes and failures, 20 and 480. We sampled randomly, and we sampled underneath 10%, 2,000 of the population of interest. So this is a good setup. Okay, up next again, hypothesis testing. Now we're trying to see if the expected amount was different than 500, so the HO should be equal to, and the HA should be not equal to, and they both should involve the assumed 500. So it's A. Don't use sample data. Don't use, see it says sample 503. Don't use your sample in your hypotheses. Okay, only use the assumed truth in your hypotheses. And again, HO needs equal sign. HA, make sure you read carefully. I know I'm still speed reading, but carefully find what it says. Different just means not equal to. All right. So again, interpreting type 1 error, a common thing. So what would it mean to reject HO when we shouldn't? That would mean we would conclude that it's less than 8.9 when it actually isn't. So, all right, again, that's when you reject. If you're rejecting HO, you're saying HA. So which one says going with HA, saying it is less than when it's actually not? So it is actually 8.9, but they fail, or wait, sorry. It is lower than 8 point, no? Wait, complicated wording. Okay, so it is actually 8.9, but they conclude it's less. So get your wording straight, but that's what that means. Rejecting HO, saying this is not true. In other words, going with this, when this is actually true. How many more do we have? Oh, good, one more. All right, so we've got a proportion test, and we're doing not equals to. Ooh, this is a tricky question. It's a good thing we at least saw this one last. And we got a p-value of negative 1.5. Now here's the trick. This is a not equals to test, so here's what that means. Let's just assume this is where z equals 0 is. We'll not assume that is where it is. Let's assume this is where the z-score of negative 1.5 is. In a not equal to test, you need to take all this area and double it, because if it's not equal to, it's just as likely you could get 1.5 or above. So we need to find the area here and multiply that by 2 to get the total, or in other words, both sides. So let's do that. Where is the z-score of negative 1.5? Negative 1.50, it's right here. So we get 0.0668. Now that's how much area is, again, on the left and down, but this is a not equal to test, so we also need to know how much area is above, and it's the same amount, just doubled. So that times 2 gives us a p-value of 3 decimal places. They told me around 2, so 0.134. And there we go. So I know I went through fast. Hopefully you're able to pause the video and see the wording of the questions and see how I got my answers. Best of luck. Keep on studying.